And I should be live. Welcome to Signal Minutes. Signal Minutes tonight. Advent of Code, day 10. Before we go to day 10, I first want to quickly go over the code that I have right now, and I should probably have turned on my phones already that I can actually see if I'm properly live or not. And I tend to always forget that. Okay, so this one is up, and let's also open up Twitch so I actually see all the chats. Hey Minadal. So I have worked a little bit on on day 9. I was able to finish that, and I was able to finish day 8 part 1. Part 2, yeah, I'm not there yet. Boom, 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 boom. I should be live right now, but it does not really show that I'm live. So, Okay, let's see if that does the trick. So we have 4 people on YouTube, but chat is not appearing for some reason. Okay, now it is. And on Twitch just kind of refuses to work apparently. Oh well. So let's make this a little bit smaller first. So yeah, part 1 of day 8. I want to quickly go over it, but it's a mess. So for the people who quickly want to pause to see what day 8 is, yeah, it was kind of an annoying one. I was able to make it work, and I was stuck on some part very, very long. I could not get the test data to work correctly, and I was almost 100% certain that I finally understood the question. So let's go over it. So I have my boxes that I make into a separate array, because I will also need those for for part 2. Each index corresponds to a circuit ID. Then I have my circuits and the distances. The distance is basically an array filled with different arrays with first value distance, second one main box, and best box. Yes, I keep using those terrible naming things. And yeah, from here on out it gets kind of messy. So first of all, I fill the whole box circuit ID list. I get the distances. Then I sort the distances, and I kind of want to create a new one because I feel like we also need to sort them for the next part. But I'm slicing them here. Yeah. So wait, do I need to slice them? I don't actually think that I need to slice them. What we get for day 8 right now, we get 40. Pum, 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 pum. I guess I can just do this. And then we don't need to slice it. But I can just create the distances inside of here. Boxes. And that way I can reuse the distances for part 2. Okay, so that works. Okay. So yeah, there we go over each closest pair, and that is basically a full-on loop. But what I was stuck on the most, box sizes equals 1000. And we need to get first 1000 closest connections. For the test data, we have 20 boxes, but we only need the first 10. And yeah, I was just checking boxes.size, but that was wrong because test data is 20 and not 10, like the amount that we need. So that was where I was going wrong. And it took me so long to figure that part out. Luckily, I was able to find it out. And yeah, the next part of my code, it's a mess. Suzuka is there. Okay, so first of all, we create a new circuit if both of them are empty. And yeah, my naming, it's probably not the best, but it works. Yeah, like it's a lot of text. I think there are probably like better ways of doing this, or like making variables for some of these things, but yeah, it works. Then we add main box to best box circuits if best box is already in a circuit. Same for the best box to the main boxes circuits, and then check if they're in the same circuit. And this is the part where I was going wrong. If one of them is in a circuit, no, wait. So we checked if they belonged in the same circuit or if they did not have a circuit. But it's possible that we need to merge circuits, as one could be close to another one which is already in a different circuit. So they could both be in a different circuits, but actually they should merge because they're like part of the same circuiting. And this is a part that I got stuck on last time, and I feel like this has been taking me the most amount of time. Yeah. I also realized something. Like I'm transferring them one by one, but I can normally just append an array like fully. I can probably do this. Oh, whoops. First of all, let's get rid of this one. Distances, we don't need this one anymore. So part 2 becomes a little bit smaller. Now we got 48. Yeah. Okay, let's not do that. So that is needed apparently. Oh well, anyway. So we check if they're in the same circuit, and also merge all these circuits together. Then we sort it again to get the biggest ones. So we get 0, 1, 2. So to get the 3 biggest ones, we multiply them, and voila, we have a working thing. 40. And I don't remember why I put it on -1. I think it's yeah. But basically part 2, part 2 does look easier. Like it's also a lot shorter. But that's not what I will focus on today. And before I move on to the next one, let's put these on 10 already. So, day 9. We were able to finish part 1, I think, but part 2 was kind of an issue. I was able to really optimize part 9. The first time when I ran it successfully, it took around 16 seconds, 17 seconds. If I run this one. Now part 2, it does take time, but less than a second, I think. 600 milliseconds is less than a second, I think, yeah. So this works now. The main thing that we're doing is, it's basically a circle. As I talked about in the last stream, I noticed that this data was kind of like a circle, but with like one big gap in the middle. But that gap is on the y level, so on the height. So what I did was just create a distance array. So line y, like line 1, the closest point is this, the furthest point is that. And then when I do that, I calculate that for every single thing. So we just have an array of every line with the distance, like the minimum distance and the maximum distance. And then I just check if the size of the rectangle that I found, if it's actually like within the rectangle, the circle thing, by just checking if it's inside of those boundaries. And that's, yeah, basically how I did it. So I just checked the boundaries. I first have a quick check, because if I don't do this, it takes a very long time. So if I do this one out, this will take long. Like, very, very long. So yeah, optimizing. We basically check beforehand if the top left corner and the top right corner, if they're within those boundaries. Then we check for the bottom boundaries, but then we also check for the middle boundaries. And only this check alone already causes it to be twice as fast. So yay. And then we have a long check, and that's why we need those quick checks first, because this will check every single value, like every single edge, if it's inside of the area. I should probably show my screen for that. So we have the quick check and we have the long check. And that is basically day 9. So day 9 is working. And up to day 10, first of all, let's put it on test data. I should really change this, so I don't always have to comment the correct one out. And we go to day 10. Normally it should be... No, it's not live yet. It's not live yet. It's still 10 minutes. Well, yeah. I honestly didn't expect that one. Okay, and I see that one of the phones is almost out of battery already. So Twitch chat, you'll be gone. I'll just turn this one off, because that one will keep complaining about me. So yeah, I guess I can try part 2 of day 8 for 10 minutes. So the L's are right, they definitely don't have enough extension cables. You'll need to check connecting junction boxes together until they're all in one large circuit. Continuing the above example, the first connection, which causes all of the junction boxes to form a single circuit, is between the junction boxes. Continue connecting the closest unconnected pairs of junction boxes together until they're all in the same circuit. What do you get if you multiply together the x coordinates of the last 2 junction boxes you need to connect? Wait a minute. No, the thing that I was thinking of doing was completely different for the 8. Oh, whoops. So I was going to loop over all the... Oh, oopsie, wait. Might be doing dangerous stuff. So our youngest kid, today, he learned how to stand up by himself. What he did not learn yet, and what he is learning right now, is trying to sit back down. He just keeps falling on everything, so I always need to make sure that he's... If he tries to do his standing stuff, that he's actually like surrounded by a pillow or something. Yes, you're dangerous. Ah. Oh. Yes. He's a happy kid. He's a happy baby. Okay. I wonder what today will be. I don't think I can do part 2 of day 8 within the time that I have. Or I guess I can... Let's try to do just this. But we take all the boxes. We need to connect all the circuits. Let's return 0 for now. I'll also need a... Whoops. Circuit. Do I need box circuits ideas? Maybe. Okay. But we should go over every single one. And I should probably 4x whoops. For I int in circuits, and let's just print circuits I dot size. You need to create one large circuit, so they all need to connect to one, be connected to one circuit. Unable to iterate over it. Oh, whoops. Let's see. Do we get one giant number and then... I guess I'm still on the test data. Yep. Let's see. I think that will be extremely slow. Oh no, that's actually reasonably fast. We get a lot of 0, but you don't get one big array, like a big circuit. Like they're still kind of like not connected. Continue connecting the closest unconnected pairs of junction boxes together until they're all in the same circuit. But how can they get into the same circuits? For example, the first connection which causes all of the junction boxes to form a single circuit is between. Wait, for the test data, do we just have like 2? Like, do we just have like 2 large? So we only have 2. Okay, I guess I can solve this within the 5 minutes that I have. Okay, and baby 2 wants to go again. Oh, whoops, and I was not showing my screen. Again, I'm very good at not showing my screen. So, what I was doing, I got this, and I got 2 arrays, and if I do this, oh, whoops, with the biggest data, I have multiple arrays. It does take some time to print everything. If array dot size is bigger than 0, this will print a little bit faster, I think. So we still have quite a lot of arrays. A lot of 2 that are not connected to anything else, but we need to get them all. We need to get all the last ones. Can we do this? So, wait, do we have an answers here? Answers, no. Bar total int equals, okay. So, fact int array. We need to make certain that there's no 0 inside. And we need to get the last value. So array minus a 1. And we need to get the x. Wait, how was the data like? Was it x, y, z? Yeah, x, y, z. So the first value is x. Total dot append array dot x. Unsafe argument append requires the subtype int. Okay. What is it complaining about now? Unsafe arguments. Unsafe call arguments. I think I can finish this. So we're doing this and then total dots read. Oh, it needs to be a normal array, I guess. Now we also don't need this one. Reduce func product. Let's try to find it. Oh, day 8. Total dot slice. Oh, slice, and we need to go from 1 till total dot. Oh, total dot size. Do we need the second value here? Oh no, we don't need. Okay. And then we reduce with product and we use total 0 and return the value. So I think need to be away for a bit since all devices are used for Ghibli park tickets. Oh wow. Oh yeah, the whole like lottery system here in Japan. Good luck with that. Okay, let's see. Day 8. Do we have the correct... Oh, I'm still on the full data. So we get 5742. That's wrong. The first connection bit causes all the junction boxes to form a single circuit. Am I... That's... Oh. Am I getting the wrong ones? 352. No, that's 216. Where's 216? I cannot even find 216. 117. 117? Wait, 216 or the 216? Where is 216? I don't see any 216 in here, so I think there is a mistake in my code. Oh wait, did I actually put the correct title onto it? Yeah, day 10. And on here, day... starting soon? No, okay. Yeah, no. Oh well, I'll leave day 8 for what it is for now, and I'll go to day 10. So up to day 10. Wait, it's 5. Okay. Day 10, factory. Just across the hall, you've... Oh. I should probably have put the microphone next to my face. Sorry about that. Just across the hall, you find a large factory. Fortunately, the elves here have plenty of time to decorate. Unfortunately, it's because the factory machines are all offline, and none of the elves can figure out the initialization procedure. The elves do have the manual for the machines, but the section detailing the initialization procedure was eaten by a Shiba Inu. All that remains of the manual are some indicator light diagrams, button wiring schematics, and jolted requirements for each machine. For example, okay, this is looking fun. The manual describes one machine per line. Each line contains a single indicator light diagram in square brackets. Okay, these are the lights. One or more button wiring schematics in parentheses. And joltage requirements in curly braces. Oh, I think this will be a hard one today. To start the machine, its indicator lights must match those shown in the diagram, where dot means off and hashtag means on. The machine has the number of indicator lights shown, but its indicator lights are all initially off. So, an indicator light diagram like dots, hashtag dots, means that the machine has 4 indicator lights which are initially off, and the goal is to simultaneously configure the first light to be off, the second light to be on, the third light to be on, and the fourth to be off. Okay, so all lights are initially off and we need to create this combination. You can toggle the state of indicator lights by pushing any of the listed buttons. Each button lists which indicator light lights it toggles, where 0 means the first light, 1 means the second light, and so on. Where you push a button, each listed indicator light either turns on if it was off or turns off if it was on. You have to push each button on an integer number of times. There's no such thing as 0.5 presses, nor can you push a button a negative number of times. So a button wiring schematic like 0, 3, 4 means that each time you push that button, the first, fourth, and fifth indicator lights would all toggle between on and off. If the indicator lights were pushing, the button would change them to be instead. Because none of the machines are running, the joltage requirements are irrelevant and can be safely ignored, but we will need them for part 2. Oh, what's this? Okay. You can push each button as many times as you like. However, to save on time, you will need to determine the fewest total presses required to correctly configure all indicator lights for all machines in your list. There are a few ways to correctly configure the first machine. You could press the first button 3 times, 3 buttons once each, a total of 3 button presses. You could press 1 3 once, 2 3 once, and 0 1 twice, a total of 4 button presses. You could press all of the buttons except 1 3 once each, a total of 5 button presses. However, the fewest button presses required is 2. One way to do this is by pressing the last 2 buttons, 0, 2 and 0, 1 once each. The second machine can be configured with as few as 3 button presses. Okay, so it sounds fun, but also kind of annoying. Oei, oei. So one way to achieve this is by pressing, let's just skip those things. So the fewest button presses required to correctly configure the indicator lights on all of the machines is 2, 3, 2 equals 7. Analyze each machine's indicator lights diagram and button wiring schematics. What is the fewest button presses required to correctly configure the indicator lights on all of the machines? I have no idea how to start with this, but I'll first have to look at my kids because they're trying to kill themselves again. And I'm back. The kids are watching television, so hopefully they can sit still for at least a couple minutes. So yeah, this is I kind of like this one and I dislike this one at the same time because of the next part. I can already tell that part 2 will take me a long time to figure out. So let's create a machine class. Wait, they're all machines, right? They're machines. Class machine. We have the var state, which is an array of bools, which is just going to be the default state. So put on all null and then desired state. Desired state, which will be the correct thing that we need. We will need a init function. Okay. We will also need an array probably for the calls. Yeah. For this, I think I can use how's it called? Lambda functions, I think. Yeah. Is that just like no, callable, I guess. Yeah. And let's just call these buttons. What I do wonder now, if you press the today's description is quite long again. And the first, the fourth, and the fifth indicator lights would all toggle between on and off if the indicator lights were. So I guess we can create different combinations of the numbers until we get like the correct. Yeah. Hmm. Let's make this an array of an array. Or like a packed int array. Let's also first copy the test data answer so we have that stuff go in here already. Okay, let's get my puzzle input from here. How many lines do we have today? 177. But do we do this? Calculate buttons. Instead of bool, let's make this a packed int array. And over here as well. Otto Tisak is there. Just a moment, my kids are breaking the television now. And the kids are fine now. For about 5 minutes again. Oh, well, so I will work with numbers, I think, instead of bools. And that's why I can use the, modulo function. Use modulo 2 equals 0 is off and 1 is on. Okay. So we have function calculate, and this will just return the number of button presses. Okay, let's create an init function. Func init. Let's create a new array for all the machines. I do think we can probably let all these machines, like all these things, run inside of basically a thread each to speed up the process, because they don't interact with each other, and hopefully they won't interact with each other. So we have an array of machine for a line string in data.get string array data paths print online Let's run this. Let's first reset this. So we have our 3 lines. Get the all light indicators. Then we need to get buttons. And then we need to get joltage. And I should probably also create a joltage thing already, but I have no idea what I need to do with the joltage stuff. So, let's just put it in an array already, just in case. So print line. We have our line. Can we split that? How can we easily split this data? Kind of like get var lights string equals line dots for this I could split it on on this part. I shall probably let's call this parts. Let's split it on here, and let's also split it on this one. So we get the 3 arrays then. Yeah. Oh. Cannot find split in the packed string array. Oh, Ah, yeah, of course it will also. So we have our lights. Let's just do that first. Then we have our buttons, which is a string, and we just take our line dots left, I guess. Returns the first param length characters from. Wait, can I do this? No, substring dot substring, and then I just do line dot find and line dot find. So that's the buttons. And now for the jolted, I split the line with this. Print lights buttons jolted. Oh. Oh no, yeah, we should probably also do substring for this. Line dot find 0, and over here exactly the same thing. So substring line dot find. And does this automatically go to the ends? Yep. So we should get all 3 areas. Okay, so we have our dots. We have it does include that one part. But can I do this? Oh, crap. Yeah. Buttons equals line dot substring 0. Okay. This should work better. Nope, it doesn't. Oh, well. Um, okay, so we had a miracle got to position 350 on one device, others were 910k plus. The lottery system here in Japan, it's terrible. I'm glad I don't really go to those kind of places and that my wife is not very interested in going to those things as well, because I hate those kind of things. First of all, you need to get the ticket, and then you spend your time in a overfull park. Well, sometimes with the lottery system, they actually like manage to do it in a smaller amount that is not too busy, but you never know. Got my tickets for when my parents come over in February. Oh, that's fun. How's it going? I'm trying to create machines. Yeah. I like oh whoops. Let's do part by part. So we need to do this, and then we right minus substring print all lights. So that does include the last like minus 1. So I guess that will include the correct data. Okay. And then for lights dot replace, and does replace give a new string? Yep. So lights equals light dot replace. We replace the dot with a 0 because that should be off. And then 1, that has to become a 1. And we also need to create a new machine. So var machine dot new lights. But we only need, yeah, we only need like the desired state. So it's an packed int array. So desired state equals a light. So that's one thing done. Now the buttons. Buttons equals available buttons, and then jolted equals. I have no idea what to do with the jolted chat, so this will be another packed int array. Oh. That will be an array of packed int array, yeah. Let's do the naming a little bit better. Oh, whoops. B and J. Oh, I need to be careful when I do things with J, because if I double press J, that's also to go out of input mode. So it's kind of. Are you going for the brute force approach for part 1? No, I don't think so. I don't actually know like how I could easily do this though. That's like one of the issues. So I might have to brute force it. It does depend on how many possibilities you can get, obviously. I think I will try to find a way to do each slide on 1. Like to get each slide in the correct. Wait, my kids are doing some stuff again. 危ない。危ない。No。壊れる。なんであ、一個にしたね。え私パパ取られるよ。うん。見て見て。Voila. Since pressing it twice means going back to the previous state. Well, the thing is, you can only press buttons once or 0. The possibilities are endless. It's just trying to find the least amount of like button presses to get the correct answer. I will calculate each slide once and how many button presses that takes and which button presses. Oh, this will be... It's fun and annoying at the same time. Pressing a button twice is always useless. Wait a minute. You could press 1, 3, 2, 3 and 0.1 twice. Wait, why do you need to press this one twice? Yeah. Okay, so well, it's actually easier than I thought then. It's not going to be too difficult then. But why is this can I pass? Oh. Okay, well that makes it easier. I forgot that there's like only on and off for each thing. So, but the buttons. Okay, I just need to find all the possible approaches. So basically, I kind of need. It's just a confusion, yeah. Okay, let's go to jolters next because that's probably the easiest one. Var jolted. It's a string. Oh wait, we should probably the lights should be a packed int array. So we can I split between nothing? If I split between nothing, what do I get? Oh, whoops. Oh. If I split between nothing, I get what I want. Okay, that's helpful. And then for the volt, for the joltage, I do line dot substring. I need to line dot find this one, and probably plus 1, and then line dot find. Or I can just do -2, I guess. Oh, that's empty. Dot. I just need to remove like the last character. Okay, I can do it like this, and then for jolters, I just do jolted dot split between the commas. Okay, so we got jolted. Now the buttons. The buttons will be a little bit more annoying. So var buttons string equals line dot substring line dot find, and let's just go for the first space. Print buttons. What is this complaining about? It's not being used. Okay. No, that's not a problem. We do need to do this plus 1. And then buttons, button string, oh no, button equals buttons dot substring 0, comma, buttons dot finds, and we look for this minus 2 minus 1. Okay, so now we get all the different areas. So now we can just split this by 0 and fill in our array. Okay, var button groups, it's basically an array of packed int array. Yep. Array of packed int array. I feel like for this challenge, for this day especially, it's a lot of like the biggest problem will just be doing the data, like getting the data correctly, I think. So button groups, we go over for group, which is a string inside of buttons dot split. I split according to the spaces. Then var entries, which is a packed string array. We take our group dot trim prefix trim suffix dot split according to the comma. Okay, so this is a long one. And could I technically do a packed int array already? No. Then for entry string in entries button groups dot append int entry button groups. Where does it go wrong? Okay, so we have 81 errors in it, then push back of type int into a typed array of packed. Why would it not work to put a integer inside of a packed int array? Oh, no. Okay. Button group. This is a packed int array. It's a new one. Button group. And then button groups, we append or button group. Okay. And this should be correct. Yep. Okay, and now we can get rid of this. We can create our machine, and I guess we can just do machines.append, and we append our newly created machine. Let's also pass our button groups, and this should Function argument 1 should be a packed int array, but is a packed string array. Lights. Okay. Okay, and then for lights, yeah, lights in a string in lights dot splits. Oh, and we need to get lights array dot append integer light and voila. Okay, so now we have all the correct machines. And lights array. Okay. This should... trying to assign to a in 58 desired state lights. Yeah, no, it's just this. Okay. So this will turn out. Yeah. Okay, we get our machines, but we also get 3 errors. Why do we get errors? Unable to convert array index 0 from string to array on 39. Oh, let me guess, the voltage. Voltage array is a I guess the voltage, yeah, it's just numbers, so we just need this. Okay, let's create an empty one, and then for j string in voltage dot split, and let's take the comma. We add to the voltage array dot append int and there's something with my kids again. And I'm back. Kid's still alive, and Kid is sleeping right now. So yeah, finally. Okay, where was I? Creating the data, just getting the data correctly. Wait, what is the issue over here? Oh, whoops. And over here, jolted array. We don't even need a jolted array yet. That's for part 2, but okay. No error, so we get our machines correctly. Now we need to total is an integer. Let's set this to 0. For machine in machines. Total plus equals calculates. And then we just return, return total. Machine dot calculates. Okay, I guess this is all I need. I could also just create var answers like usual, a packed int array. Answers 0. Answers 0 and total gone. Okay, the calculate function. So pressing multiple buttons twice, yeah, I think we will need to press certain buttons twice. Yeah. But how can we go through like all possible... Yeah, the second time is just cancel the first time if all the buttons would only do this once. But we could have, for example, 1 and 3 and not have this like 1 and 3, and then we don't have this 3, but this will be a 1 by example, and only 3 should be 3 should be on and 1 should be on. Then we need... Wait. No. Yeah, no, I'm wrong. Yeah. So I need to calculate, if a single button press can work. If not, try double pressing. Continue until all buttons have been pressed. So we var var states integer. Hey Ringomar. So we have our state, which is packed int array, state dot resize and desired state dot size. So we have the exact same size, and then we can just use a modular thing to make certain that it's actually on or not. Oh, we should also fill state by 0. State dot... No, it should already be 0. But anyway, let's just do it quickly. Was watching on YouTube for a while, though I'd come over. Thank you. Let's fill it by 0. Now, how can I do this? You were on my homepage. Oh, wow. How? Like, I'm a reasonable, reasonable. I am a very small channel. Like, there's... I think I'm not even... I'm almost at 3,000. Yeah, I still have like 200 to go, well, 206 to go before I reach 3000. So I am a very small creator, especially compared to my other two channels. I'm more active on this channel though. Hmm. The homepage could be because you recently got affiliate status or something. On Twitch maybe, yeah. On YouTube, no idea. I'm in program videos bucket. I prefer, like, if I watch YouTube, it's a lot of the times just a homepage on YouTube. Honestly, I don't know Twitch enough to like. I don't know Twitch enough to like know how it actually works to get like found. Yeah, I don't really use Twitch except for streaming. Okay, so you may not know I have two kids, and suddenly it's very very quiet. And kids being quiet, it's not a good thing. Okay, one is sleeping, one is almost sleeping. I was watching a girl explain the code in fighter jets. Oh, sounds interesting. Yeah, I've been seeing you getting up, lol, and checking. Yeah, my two kids. It's kind of a challenge. For buttons is a packed int array in buttons. Calculate. I will make them separately now. These for loops, and I'll make them better later on. If state equals desired state, we are return 1. So state for I int inside of let's call it button group to make it a little bit easier to see. Oh yeah, I think I saw the one in my feed about how you use you only use some features of the language to avoid undefined behavior. Oh, I will have to look that up. State I plus state I is state I plus 1 and then modulus 1 2. So I hope this works. I actually don't know if this will work correctly or not. And I guess for the 2 button presses we just take button group A, button group B. No, we should go I X J. Let's just go J. Oh, whoops. I should probably create this into like a separate yeah. Func. Oh wait, how do I? No. No early optimization. Early optimization is what always gets me in trouble. Yep, probably not something you need to think about so much. State fill 0. So we start by always filling it with 0, but then we need to add the buttons from button group button group A and var button group A This is a packed int array. I dot size dot size. Oh, whoops. This code will be a mess, but I promise I will clean it up someday. And this will be buttons I. And let's replace it by Y. I feel like Y is a better thing. We get button, let's just call this button group. And button group dot append array, and then we just take button group A. How long have you been doing Advent of Code? I've been doing it since like last year. I did it from the first day to the day 16. Then I had to give up because it was consuming way too much time. I was way too stuck on certain days, causing me to lose over 4 to 6 hours in a day. This year has been better, but I have been stuck on day 8. I was able to finish part 1 today, but part 2 will require more time, but I gave myself a limit of 2 hours, maximum 3 hours. Like 2 hours on the day itself and 1 hour afterwards. And I'm already kind of over my time, so I don't think I will finish day 8 part 2. Because it just consumes so much time, and when I get stuck, yeah. So during stream, I spent 2 hours trying to solve that current day. And afterwards, I will, if it's not done, I will spend 1 more hour. If I cannot complete it, it's for future me. For when I'm smarter. Okay, print, oh no. Let's see. Wait, was it not a single one that requires like 1 button press? Oh. I think, the fewest button presses required is 2. It's always 2. What is going wrong here? Oh wait, and this should be 2. This is always prints. Oh no. So what is going wrong? So we should have 2 ones in the middle. It checks the same thing multiple times. I think there's something wrong here. Let's take an easy one. So we have, oh wait, I should also probably print, no. So we print, we press the 0, 0 twice, yes. We press 1 twice, 2 twice, 3 twice, 4 twice. 0, 1, 2, 3, 4. Is that a 0, 1, 2, 3, 4? 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Okay, that's this one here. I should probably do this +1 so we don't do the same button twice. We got 4. Okay, so we're getting something. But value is an integer. How long have you been doing Advent of Codes? Are you also doing it every year, or? I feel like it's getting more and more popular each year. I don't like it anymore. Because of the 12-day thing, or just because it's too complicated, or it's too time consuming? Like, honestly, the reason why I would stop is just because it takes a long time. I still do it because, for me, I'm still learning a lot by doing this, so... Like, right now, I'm basically brute forcing every single, like, possible thing. For this we have how many different answers? So 1, 2, 3, 4, 5, 6. I don't. How can I easily loop between all the possible combinations without having to do it manually? Now let's quickly go to google.com. Oh, whoops. No. Okay. How calculate the total amount of combinations in Godot? Oh, wait, I am dumb. I am so dumb. I don't know what the old ones used to be fun. These ones feel tedious, mostly because I never get to reuse what I learned from them. Yeah. Yeah, like I thought I will be able to reuse some of the code from last year, but so far that has not happened at all. So yeah. I don't think this is the kind of like code stuff that you would actually be able to use in actual programs. It's just it's kind of it's just like, why do people do puzzles? Kind of same thing, I guess. I'll just create an array of available combinations. Var combinations, which is an array of, whoops, packed int array. Oh, whoops. So, for I int in, oh, and we have a person who really likes to be banned. Why did you choose Godot? I'm basically making a video editor in Godot right now. If I quickly go here, go Zen. I'm making an open source video editor in Godot, and my channel is mainly about Godot and asking people on my channel what I should do the whole Advent of Code in. People voted Godot, so Godot it is. If I were to have chosen the language by myself, I think I would have gone for Zig. I'm really interested in Zig, but it's very unstable in the way that you may like a certain feature, and with the next update, it's gone because they're still not in a 1.0 state. It's still 0.1 beta. Yeah. I really like how Zig works. Like, I am very interested in that language specifically. I really want to get more into it, but time. Time is also kind of, yeah. So var combinations int in buttons be combinations dot append. But here is the problem that I'm having now. Okay, this kind of like looping always messes me up. Hey, pause, what was scrolling? I wasn't scrolling. Combinations, append, I should append buttons. Size times buttons dot size. Okay. So we have but this will no, this will create an array that will be way too big. Yeah, no. No. This. But how many different, like, instead of this one, by example, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12. But we need to get the fewest button presses. So what I would recommend is making a function that computes if a given solution is right or not. And search solutions as an array of bool. Yeah, that's... Oh, binary! Binary, that's it! That's it! Binary! Like, I don't mean like starting to work in binary, but I can just do button... Oh, whoops. Button presses, which is an array of bools, indeed. So button presses. That's resize. That's a very smart idea. Thank you very much for that. I would not have come up with this by myself. Buttons dot size. Let's also put this on here. Okay, so button press, and then we just have a while loop while true pass. Okay. So we resize the buttons, and then button presses dot fill with a false, and then this one, the state, we need to... Well, we can fill that later. As long as you don't have more than 64 of them, it will be fine. Yeah, I think this is probably the best way to go about it. Like, it can be seen as early optimization. Like, I could just have written this for 12 times and just brute force it, but this script will be... It's already over 100 lines. Ow. Oh well, anyway, so while true, so basically any combination will give something. So I don't need to, like, put an if statement in if all buttons are positive. So while true for I int in range, gonna go from like buttons dot size to 0. I can just do button presses, I guess. Okay, so no, I should just do if I button presses I plus wait. No. No wait. Oh. How will I do this? Okay. This made sense in my mind, and now I am kind of stuck on how I was going to do this. If the last one is, I could just do it in reverse. So but I use bools. You wait. You could store them in a big integer. To be honest, yeah, probably. If button presses I equals is I'm giving up on part 2. Wait, on what part am I? I think I'm still on part 1. Yeah, part 1. Wait, what is part 2? What is part 2? Like, is like, what do we need to do with the joltage? I'm still stuck on part 1. One way to do it is to use the power of maths. Button presses plus equals 1. If button presses I equals 1, equals 2, then button presses I becomes 1, and this one becomes plus 1. Wait, why is oh, same mistake as before. Var turn int turn minus equals 1 whilst turn is not 0. Let's just quickly print this to see how, if this actually works. Okay, so 1, plus equals 1. Okay. Out of bounds. if button presses dot size is equals I plus 1, then we break. We don't need this for the code, so 1, remove this later. Because we will never reach that point normally. But normally we should have, yep, yes, I made something. I made something that works. It's gonna be very similar, except the buttons are going to increase by 1 their value. Pressing 2, 3 makes. Then you gotta match the jolted. Oh, eh? Okay, by the way that you're describing it now, I feel like I will just give up on part 2 before even trying to start it. Okay, so state dot fill, we fill it with a 0. Var button group, it's a packed int array. So create button group. For I int inside of button presses, if I equals 1, then we button group dot append buttons dot I. Append array. Okay, I don't want to remove my old code yet because I feel like I miss. Yeah, I should probably have done this. And then I just return the button presses dot count. 1. Okay. Okay. Felt. Normally it should not like do the whole felt thing. Why? You can write it as a matrix multiply and fold the matrix to be just a single loop since values can only be 1 or 0. That's, I am not 100% certain how to do matrix stuff. Completely honest, I have no idea. I want to learn more. But I feel like that's really going beyond what I know right now. Okay, so why is what? Can I print as states? Let's see. Oh wait, it goes out of bounds at 89. But how can it be going out of bounds? Normally it should only go like 10 times. Like it should hit the correct combination before it goes out of bounds. Why? Wait, why does it only loop between those two? You don't actually have to write the matrix in your code, just a way to visualize the problem. Ah, okay. Why? What is my part 1 solution was to use bitmask. Yeah, that's I am doing a kind of bit mask. Bit mask and multiplies and popcorns. Pop CNT. Let's call it pop CNT. I have no idea what pop CNT is. Pop. What did you make me say? Is that an actual thing? Wait, before I get like demonetized or something, pop CNT. Is that an actual thing? Okay, so pop CNT is an actual thing. Okay, well, I okay. Okay, well, sorry, wait, why does this not work? Why, if I equals 1, normally the button... Oh. Okay, where does this get stuck? It gets stuck on the first one, because it cannot find a valid combination. There's nothing wrong with my code, except for the part where I actually like create the button presses, I think. So in button group, let's print button group. So 1 3 1 3 1 3 1 3 1 3. Oh no. Dot size. Okay. And voila, it does not work. If button presses I, okay, we do seem to get further this time. Okay, let's print our value. This should work, but it doesn't, because we get our first number, and our first number is 3. It should be 2. Oh wait, no, we're not checking for like the... Yeah, we do need to check all the var presses back int array. We need to go through all of them. So presses equal dot append. So. Wait a minute. We don't go through all of them. We don't go through all of them. God. No, this approach won't work. It sounds like a good idea, but oh wow. For example, you have button 1 and button 3 that set the value. The binary represents... Then you do, and it gives you... Yeah, well, I just realize this. This won't work. Um. Oh, maybe I can do this. 4. No, this won't work. This won't work. This won't give us all the possible combinations. This won't work. Då kör. I thought this would work, but this cannot work. We will always we will never be able to go over all the other numbers individually or by 2 or by 3. So I think my previous method of just trying to like brute force it was probably the right way. For I int in the button presses, let's just remove this. Then you, yeah, but that like the whole approach that I had right now will just keep using the first one, next one, first one, next one, next one, the first one, next one, yeah. Oh wait, no, 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 no. No, wait. I'm dumb. We never said this should be null. Oh. If I plus 1, but no. Now we're getting out of the. Let's see. Do we actually get like something correct or not? This is taking a long time. We have 3, 4, 2. It will go through all possible combinations. So we do this. We remove this one. It will always sort. If button presses dot count 1 is bigger or equal to button to presses 0 to the smallest amount, then we just continue. We don't need to do all the calculations. So button presses will automatically have buttons dot size. Let's do this. Okay. I'm certain that this will give us the correct answer. But it will take time. We do still have the print after 1 is done, so best of luck, my brain hurts. Yeah, same. For the past, like, I've been doing this now 10 days in a row. I'm so glad. I'm so glad it's only 12 days this year. Because honestly, if it was 24 days again in a row, I don't think I will be doing daily live streams or like that I will be doing add stuff code at all. Like I was looking forward to it, and I was kind of on the fence, like will I actually do it or not? But the moment that I saw the notification that it would only be 12 days, I was like, okay, this is a lot better. Like even after today, there's only 2 days left, and then with 2 kids and my whole family here, I can actually spend Christmas not having to like think about puzzles. And the rest of this month, like starting from, well, we have a birthday party on Saturday, but from Sunday I can work fully on Gozen again without focusing on this anymore. Starting like on the 12th, I may be too busy to actually do the challenge, so I may have to do day 12 on Sunday. Let's see how that goes. Okay, but this is taking way too long, so something is not going correctly here. I think we're still not doing all the possible combinations like that. Or are we? Print button presses dot count 1. Okay. How about I just do presses and that's an integer instead? And presses is just let's just do this. And presses equals minimum presses. Okay. We can actually like keep a counter, I guess. Count int equals 0. Count plus equals 1. So we count and if count equals buttons.size times presses. I should probably also print presses just to have like a quick to go out way. So let's just break at that point. Because then we probably have the smallest solution. We have 5. We have one that is at 5. New presses. Wait, it says that in 3 button presses that's possible. Oh yeah, no, it should be 3. It should be 3. Okay. So it's actually the correct amount. I wonder. I guess I can do if button dot presses var presses now is an integer, button presses dot count 1 if presses now is smaller than presses. Oh wait, no. Equals to -1. Break. Does it work? Does that work? 2, 4, and okay, so I feel like we can do this. If presses is not equals to buttons.size and then we can just return presses now. We don't need to break anymore. And else presses now. Okay, I think we got it. The last one is taking time. So I think I still will need if count equals is bigger than button presses. No. Buttons dot size times presses. We break. Okay, let's see. Then we get 5. Two, two, two. Okay, that worked fast. Let's see if we get the correct answer now if we do the normal data. Let's see how fast this works. I think, oh, that's actually reasonably fast. But is it the correct answer? Let's see. That's not the right answer. Your answer is too high. Curiously, it's the right answer for someone else. Well, yeah, that's great. You might be logged into the wrong account. Nope, I am not. So it's too high, so we're probably exiting too early. And that's probably to do with this thing here. Nope. No, that's even higher now. No, my answer is too high. And my answer was it should be lower than 550. My early break system is not working great. But normally we should still print the values. Yep. Nope, this is not it. This is not it. We're breaking too early. 540. Let's see. Like the whole reason of breaking early is just because we probably have the correct answer at some point. So that's not the right answer. Your answer is still too high. Okay. So my breaking early tactic right now is not really working. Do I do times presses again? Yeah, 499. But if I do times buttons dot size again. Okay, we get the same amount. So I think I need to wait 1 minute before submitting again. 11 seconds left. Okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. It's still too high. Will I really need to... This early braking is not going to work, I think. At words, that's... I'm not going to do that. I'm not going to do that one. No, I think like right now I need to wait like 5 minutes. I know 1 minute. Okay, so they did reduce the time to 1 minute. No, I think it used to be 5 minutes. Only submitting like every 5 minutes. So, well, we're already checking if the amount of presses is. We have. Yeah, there's basically a lot of stuff going on now. We don't need to count anymore. That does not really do anything. Let's get rid of this button group. So for X in buttons, let's try to speed up the code that we have. Okay, I think this will already speed up by a little bit because we don't need to create new arrays the whole time. As of now, not a single one has finished. You know, even with 5 minutes, if you use the right algorithm, it only takes 10 tries or so. States. I wonder which part of this is taking the longest. These button press things or... Yeah, using the too high, too low information, you can probably do it, like, guess it very quickly. That's true, but it's not the correct way. Are we actually doing this? Print tests. Okay, so we are doing this. How about we still have the counts? For counts, integer equals 0. Else counts equals 0. Count plus equals 1. Count equals 1. If count is bigger than buttons dot size times 2, then we just break. Oh, it's just buttons dot size. Max tries. Var max tries is an integer. Voila. Let's see. Is this faster? Yes or no? Not really. If count is bigger than... No, this is not going anywhere. How about we use a var count integer 0 count plus... Oh. Let's first see how this data goes. We have 5. We don't know if that's the correct answer. That's now kind of the issue. So we should probably go back to our test data. So we have 2, 3, and then it should stop at 2. So that's actually a good thing to test upon. We need an early exit. So that is one early exit. 2 early exits. The other one does not want an early exit because it's kind of stuck at some points. No, continue. Button presses dot count 1. Let's see. Wait. That is odd. So at a certain point, it only... Does it get stuck on some points? Oh! Okay, 3. Then it does the same thing. Oh wait, it goes like completely strange here. It's skipping over some... Oh wait, that's probably my continue thing. Yeah. But then it just keeps going 1, 1, 1, 1, 1, 1. Hmm. Huh. Peculiar. If I remove this one. And stop. If button presses dots count 1 equals buttons dot size break. Let's have the same thing over here. No, wait, it shouldn't. No, no. That should not be necessary. We have 7. Okay, so now this works. Okay, this works now. Let's see. This should... I tested that already. It's too high. I guess I should remove this. The early exit is not a good thing. Okay, let's see. So submit, and that's the right answer. You are 1 gold star closer to decorating the North Pole. So it was off by 1, and that's just because I was dumb and had a early exit which was skipping some good exits. I don't think we need counts. No. Okay, well, part 2. I'm almost, well, I'm 6 minutes away from my 2-hour limit that I give myself, so let's see how this goes. All of the machines are starting to come online. Now it's time to worry about the joltage requirements. Each machine needs to be configured to exactly the specified joltage levels to function properly. Below the buttons on each machine is a big lever that you can use to switch the buttons from configuring the indicator lights to increasing the joltage levels. Ignore the indicator light diagrams. Wait, you can use the switch. The machines each have a set of numeric counters tracking its joltage levels. 1 counter per joltage requirement. The counters are all initially set to 0. So joltage requirements like 3, 5, 4, 7 mean that the machine has 4 counters which are initially 0. And that the goal is to simultaneously configure the first counter to be 3, the second counter to be 5, the third counter to be 4, and the fourth to be 7. The button wiring schematics are still relevant. In this new joltage configuration mode, each button now indicates which counter it affects, where 0 means the first counter, 1 means the second counter, and so on. Okay, so when you push a button, each listed counter is increased by 1. Okay. So a button wiring schematic like 1, 3 means that each time you push that button, the second and fourth counters would each increase by 1. If the current joltage levels were 0, 1, 2, 3, pushing the button would change them to be 0, 2, 2, 4. You can push each button as many times as you like, however, your finger is getting sore from all the buttons pushing, and so we'll need to determine the fewest total presses required to correctly configure each machine's joltage levels counters to match the specified joltage requirements. Consider again the example from before. Oh no. So now buttons can be pressed multiple times and should probably have to be pressed multiple times. No. 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 There you go. Okay, reading this, I actually feel like I will probably pass on part 2. So yeah, buttons can be pressed multiple times. One way to do this is by pressing 3 once. Yeah. I don't think I will do this one. I don't think I will be able to finish this within 1 hour, and I already spent 2 hours today. No, this will be too much. This will really be too much. Like, it's one thing to loop over all the buttons once, because it can only be on-off. But to have the possibility to press each button multiple times... No. No. The kind of combinations that you can have are almost endless. I cannot see myself doing this successfully. I'm trying to read it just to make certain that I don't miss anything. Most of the time you can see like the increase by 1. It does increase only by 1. Okay, so the increase by 1, that actually like makes it a little bit more doable, but still. I guess you could create a loop. No. Wait, but how would you even like... Wait a minute. Configuring the fuzz machine's counters requirements a minimum of 10 button presses. One way to do this is by pressing 3 once. 1, 3, 3 times. And 2, 3, 3 times. Oh, yeah. No, yeah. Nope. I will save my time today and spend the rest of the day working on my video editor instead, because then trying to figure this one out. I think this is going to be one of like day 8, part 2, that I will probably look at how other people solve it and then try to implement my own solution. Because this, I feel, this is really above my skill level. I don't see myself completing this within an hour, within even 2 hours. So yeah, I think I will cut the stream at this moment. I don't see myself solving this. So yeah. A big shout out to all my Ko-fi supporters. Thank you very much for supporting me. Thank you very much as usual. And yeah, I guess how many people we have? 4 viewers. Yeah, not really enough to like rate somebody. So yeah, I will leave it. I will leave it at this. So, thank you very much for watching. For the people who have been watching in the background, and I'll see you all tomorrow on day 11. We're almost at the last day of Advent of Codes. So far, I only have 2 unfinished parts. That's day 8 part 2 and day 10 part 2. I don't know if I will complete them this month. It might be for next month because the rest of this month might be a little bit too busy for me. But yeah, anyway, thank you very much for watching, and I'll see you all in tomorrow's stream. Thanks for watching. Bye bye.